Hello everybody. Today I'm going to illustrate how to take an antidifferential function from these two expressions. To integrate through these two expressions, we should use some methods, we should use some tips how to work with them. One of them is substitutions. Here we should just label some kind of expressions as unknown expression, then we should take a derivative from that expression. Then it should be a bit straightforward to work with this equation. Let's work. Here, we just label the sinus x as t, because when you take a derivative from both sides, ln x can be written as 1 divided by x. Here, x is given in the denominator. Okay, in this way, we can take a derivative from this ln x. So when you take a derivative from both sides, it will be 1 divided by x dx equals to dt. So it's just ending point, because we came like 1 divided by x dx is came, it's equals to dt, and the value of the ln x equals to t. So here when we just go on working integration, so instead of ln x we may put t, and instead of dx divided by x we can put dx dt. So after that, we shall take a antidifferential function from this expression. But here's some questions. When you look, here is given root. Index of roots is given. In this point, we should just simplify this expression. I mean, we should use some methods to work. Which one? We should write this expression as exponential functions, which is, we may write this one t and the numerator 1 divided by 2 dt. Then we may take antidifferential function. So here we should just add to the exponent of this expression. Then we should divide it to that expression. I mean this one, 1 divided by plus 1, 1 divided 2 plus 1 plus c. So it's just written in this way, but we should simplify a little bit. It will be t so divided by 2, 3 plus c. It will be 2 divided by 3, 2 in the root t plus c. When you put the value of the t here, because we just label it ln x as t, but we don't need the value of the t here. Only we should just need the value of the x, I mean ln x. So here we may put the value of the t here, then it will be antidifferential function of this equation. So this one will be antidifferential function of this expression. Okay, let's all see another equation. Here we may use labeling here or substitution here. Here we may just label as since second degree x as t, because here when you take a derivative from both sides, since 2x may come here, because when you label some kind of expressions, when you take a derivative from the expression, other expression should come. Here only from the sin second degree x can be come like 2x may come here. Okay, let's take a derivative from both sides. Here is given exponential function. In this kind of exponential function, we should take a derivative firstly from exponent, then from the expression. I mean, here we should just take a derivative from 2, then from sinus x. It will be 2 sinus x multiplication from sinus x, it will be cosinus x. Cosinus x dx equals to dt. So from formulas we know that 2 sinus x and cosinus x equals to 2 sinus 2x dx equals to dt. So we'll just label it sinus 2x dx equals to dt. Here is given everything. In this part we should just put all the values to this expression. So when you put here, it will be e, and the exponent since second degree x is given but it's equals to t, so we shall put it, and instead of since 2x dx, we shall put the value to dt. So when you take antidifferential function from e, it shall be again et plus c. So after that, again, as I mentioned before, we don't need the value of the t here. We just label sin second degree as t. In this case, again, we shall put the value of the t here. So it will be then e in the exponent sin second degree x plus c. So this expression will be antidifferential function of this expression.